Another thing I want to take note of that affects temperature patterns on the Earth is what we call land-water contrasts. Because land and water react differently when they heat up, they heat and cool differently from each other. So continental locations that are dominated by land, they have greater differences between the summer and winter temperatures. Land heats up faster and cools down faster and has a much more greater variation in its temperature than water does. So places that are next to the ocean, what we call marine climates, there's less difference between the winter and the summer because water has different properties. It's able to circulate heat down into the earth, down into the ocean, I should say, where land can't. So when rocks heat up, rocks don't circulate. They just sit there and they heat up. Water, because it's liquid, can move heat deeper into the ocean. Here's another way of looking at it. You have continentality. You have more extreme temperatures. The sun heats it up. It gets hot really quickly and gets much hotter, and then also gets much colder when the sun's not out. Where marine conditions are much slower because the water is able to mix and circulate. Another difference is in what we call in the amount of evaporation, because water has much more evaporation. Evaporation is a cooling process. It also helps to regulate the temperature because the evaporation is taking heat away from the water, where land does not have that same amount of evaporation. In fact, land has more what's called sensible heat. That's where heat is transferred from the surface to the air. So the land heats up and heat is given off back into the atmosphere, kind of your basic heat. Where latent heat has to do with evaporation. So water absorbs heat from the ocean when it evaporates, and then it carries that heat into the atmosphere and then releases it. So take note of latent heat. We're going to come back to it. We're going to be talking about it because it's primarily over water surfaces because of they evaporate. And it also has to do with energy that's released during storms, for example. So latent heat is an important thing. For example, it powers hurricanes. All right, so again, water heats slowly. It can penetrate to lower depth. It can mix around, and it also has a lot of evaporation. Land, on the other hand, heats quickly. The heat does not penetrate the surface. If you've ever been into like a wine cellar or something like that, you'll notice that even if it's hot on the surface, just below the ground, it can be quite cool. And because the land is solid, it doesn't mix like the water does. And because of that, it affects the climate pattern. So here, let's say when it's colder, the land is going to be much more colder than the surrounding ocean. Likewise, in the summer, the land is going to be hotter than the surrounding oceans. So for example, when we talk about monsoons, this is going to be a mechanism that creates monsoon conditions, because in the winter, the land is going to be colder than the ocean, and in the summer, the land is going to be hotter in the ocean. That's going to drive these wind patterns that we're going to discuss. This is something we talked about in the introduction, but it's the same principle. So if you look at temperature patterns for San Francisco and Wichita, Kansas, same elevation, same latitude. However, San Francisco has a much more mild temperature pattern than does Wichita, Kansas. And part of that is because Wichita, Kansas is surrounded by so much land, and San Francisco is bordering on the ocean. So it has a marine climate. Wichita has a continental climate. Here's another kind of simplified figure showing the temperature pattern of San Francisco relative to Topeka, which is also in Kansas, but same deal. Hotter summer, colder winter, because you're far from the ocean. San Francisco, close to the ocean, warmer, not as cold in the winter and not as hot in the summer. And this can be true for not just yearly patterns, but also day and night patterns. If you look at the day and night temperatures of Las Vegas compared to San Diego, Las Vegas being more continental, away from the ocean, versus San Diego day and night temperatures don't vary as much as they do in Las Vegas. Now, another aspect of this are circulation patterns, and this is going to be due to what's called Coriolis effect. The, the spinning of the Earth is going to create these patterns, but generally speaking, I just want you to know now that there's a general pattern of ocean currents moving clockwise in the northern hemisphere and then counterclockwise in the southern hemisphere. And the result of that is different temperatures of water on different coasts. So in addition to there being just the simple properties of water versus land, the circulation patterns can also play a role as well. So if you've gone to the ocean here in California, you get in the water, you may notice it's really cold, and that's because the water is circulating from higher latitudes. Right? However, if you got into the water, say in East Asia or on the East Coast here, the water in the ocean would be cooler because it's circulating up from the equator. So that can play a role as well. Now, this is a simplified version. This is kind of actually what the currents more closely look like. You have this pattern where the California current comes from up here. However, occasionally we can have a weird reversal of that, where you have a counter current that brings warmer water, more warmer water than we would normally get. And that's called an El Nino. An El Nino is where you have conditions where, so normally we would have kind of cold water off our coast. Occasionally we have a reversal of that. It doesn't happen often, but when it does, it changes our weather. So El Nino is a reversal of normal oceanic conditions. Happens about every 3 to 8 years. And because it brings more warm water, that warm water can be associated with increased amount of rainfall and storms. And then lastly, I'm not going to dwell too much on this, but now in addition to the regular surface ocean currents, there's also a deep water circulation pattern that happens called the thermohaline circulation or deep ocean circulation, also called the ocean conveyor belt. And this is a pattern, a three-dimensional pattern of water moving around the oceans over hundreds of years. So in some places you have downwelling, that the water is moving downward. The water is saltier and denser, and so it's kind of moving downward. And then other places you have upwelling, where water is coming upward. And it can take 1,000 years for water to move throughout this sort of belt around the Earth. And I'll include a video that kind of shows you this graphically. But this three-dimensional movement of water on the Earth helps to maintain the temperature of the ocean as well. If you've ever seen the movie, it's The Day After Tomorrow, where the climate radically changes, the premise of that movie has to do with this thermohaline circulation. That, I'm not saying it's likely scenario, but the premise of that movie is that this thermohaline circulation stopped and it caused havoc with our climate. So here's another view of it. Where it's cold, you have cold, salty water that's sinking, and then that can then bring it, make its way up in different places. And so this is sort of a three-dimensional movement of water around from the surface to the bottom of the ocean, all around the Earth, and it helps to maintain a constant temperature for the Earth's oceans.